Okay, 55J1.
I was here and then Megan you.
We are going to approximate a binomial distribution using the normal distribution. The binomial distribution was back in the last chapter. Yeah. You're fine. Okay.
Thank you.
Yep. The binomial. Take yourself back to chapter 4. Remember we did binomial, geometric, and Poisson? The binomial distribution, we knew exactly how many trials we were doing. We knew the probability of a success. Q was the probability of failure. And X was the number of successes we were going to have. And X would take on values anywhere from 0 successes all the way through N, how many trials we were doing. It could be unsuccessful with everything all the way to successful on every single trial. Okay. I think, because this always bothered me, why would we do this with the normal distribution? Because you're going to see it's much more complicated than just doing it with the binomial. And I struggle with, why is this here? Well, I think I just found out this year why this is done this way. My daughter's in the actuary science program, and it's all statistics stuff. And they can't use this binomial formula on the calculator. They can't even use this like with the graphing calculators. They do everything by hand a long way, and I'm like, oh, well, I guess that's why we would do it this way then. But I don't know. I struggle with this section, but I think it's for the people that are really, really moving on into statistics. Anyway, so we do things the painful way today for I'm not sure why. Okay. With that being said, we'll go on. And can you always use the normal to approximate a binomial? No. So the first thing we have to do is decide, when is it okay to use the normal for the binomial? And there's a little check. Basically, your sample has to be large enough. Two things have to happen. If your sample, or how many trials you're doing, times the probability of a success is greater than or equal to 5, I don't know where that magic number comes from, and, so two things have to happen, the number of trials times the probability of a failure also has to be greater than or equal to 5. If both of those are true, then you can use the normal. And if we're going to use the normal, the NCDF, I need to know the mean and standard deviation. And we had little formulas back in that chapter. We didn't really focus on them a whole lot, but here they are. So then use the normal with the mean equal to n times p, and the standard deviation equal to the square root of npq. So that'll be the first thing we do on a problem is, if they say use the normal to approximate the binomial, we'll go through and see if it's possible. This will be our check. I call this the check. Okay, after that, we have to do what's called, we'll call that step 1. Now step 2 is called Make the Correction for Continuity.
I like the name of several.
Yeah. Make the correction for continuity. This will take a little bit of practice for you to get it. Okay, what this does is it includes all possible x values. So what we're looking to do is include anything that rounds to x. Anything that rounds to x. So, we'll do a little explanation here before we do a couple of examples. Let's say here's the distribution. It goes from, these are not z-scores, these are data values. Number of successes, let's say 0, 1, 2, 3, 4, 5. We do 5 flip the coin thing. Okay. Let's say I was looking for the probability of getting 3 heads. So my x value was 3. Well, if I want to do NCDF, what do I feed NCDF? Nope. NCDF. What do I type in there? Z left and Z right. Well, I've only got one number here. I need to turn this into an area. So think about a number line. What numbers round to 3? 2.5. So I would back this up to 2.5. Up to just under the 3.5. 3.5 would go up, but anything under the 3.5? So if I just put the bar there, 3.5, my 3 now becomes this area on the normal curve. Now I do have a left edge and a right edge. That's called making the correction for continuity, is including anything on the normal graph that rounds to my x value. So we're going to practice this, a whole bunch of these, until you get it. So now I've got a shaded region. So I'm turning a whole number into a shaded region on the normal graph. Alright, let's practice it so you feel comfortable. Oh, look at that, transferred all that stuff. Yes. It would be under the 3 point, but my bar's got to be there. I'm going to say under 3.5. You don't. Okay. Good question, though. Make the correction for continuity. So this would be a probability question that we would have seen back in the binomial stuff. Say we were flipping that coin 5 times. What's the probability that I get between at least 2, but no more than 4 heads when I flip the coin? So I'm looking for the x to be between 2 and 4. So I do have 2 values here, but have I included everything that rounds to 2 and everything that rounds to 4? I like to make the little graph so you can see it. That doesn't even matter where they're at. 2 to 4. Because 2 is included, which way do I want to slide this so that I include all values that round to 2? I'm going to back up a half here to 1.5. So I would correct the 2 and make it 1.5. What about the 4? If I want 4 included, where would I have to go to get the rest of the numbers that also round to 4? Out here, so 4.5. So my correction for continuity would be to make it 1.5, technically just a less than here, and I won't mark that wrong, but the bar is going to be at 4.5.
Why is it 4.5?
Because 4.1 would round to 4, 4.2 would still equal 4, so it's beyond where I've got this bar here. This was 4, but there's still a part of the graph that rounds to 4, and they're above the 4, because the 4 was included.
Why is it 4.4?
See, I've got it less than 4.5, so I'm not including the 4.5. I did not put an equal to here. Because this is, now I'm saying, say, under 4.5, but that boundary is right there. So, but that's the correction for continuity. What?
Why don't you get like a 4.5 for like,
You wouldn't. We're approximating. See, it makes no sense, but we're approximating that distribution, that probability with the normal. And this is what we have to do to get it close. You would never, ever get. That's why I said I struggle with this section, because it doesn't make sense to do it with the normal. Why wouldn't you just stick with binomial? I have no idea. I don't know, it's here. That's why I said I hate to skip it. Just because I don't see the big picture, I don't want to skip it, because it's here for a reason. So, we do it. I just don't know what it is. I will say this is the only section I struggle with. I'm like, why? Why is this here? Somebody thinks it's important, so we'll go with it. Okay? What's the probability that I get at most? Oh no, we're just doing the correction for continuity.
Oh, I got you.
Yeah, because I'm not even giving you the situation here. What's the probability that I get at most 10 successes? We're going to practice this before we actually throw it all together. So, you need to convert at most for me. What does at most mean in terms of my X number of successes? At most 10.
Less or equal to 10?
Oh, less than or equal to 10?
Yes.
Okay. So, if I make I'm going to correct the 10 now. The correction is a half either way. It's either going to go to 9.5 or it's going to go to 10.5. That's my only way I go is a half either way. Which way do I go though? If this is a 10, and the 10 is included, and I'm going to go less than, I see that. What does the 10 get corrected to? 9.5 or 10.5? If I want everything that includes a 10 or it rounds to 10, I'm going to go to the 10.5. So the 10 gets corrected to 10.5. Oh, yes, just less than. Thank you for catching that. Will I mark that wrong on the test? No, because I don't care if you've got a less than there or a less than or equal to. You're still going to take 10.5 and turn it into a z-score to your NCDF. So that's why this doesn't really matter. You have to know what this means, but when I write this one down, it doesn't matter. So I won't mark that wrong. All right, how about the probability of getting more than 6 successes? More than 6. Rewrite it as an inequality for me, then we'll correct it. What symbol's going in there for more than 6 successes? Greater than 6. Okay.